Hello everyone, myself Ashit Desai, Assistant Professor, Mechanical Department. Today we are going to discuss here the unit number 5 types of flow. So in that content we are going to discuss the loss of energy in pipes. In that content also we discuss the loss of head due to friction, that means major loss. So basically the loss of energy in the pipes is divided into two criteria, that is major energy loss and second is a minor energy loss. So for major energy losses, this can be calculated by Darcy-Weisbach formula or Chase's formula. So this is the method for finding the major losses. So actually major loss is nothing but the friction loss. Okay. So whenever the loss is there in a pipe, so that may be major or minor. For major is nothing but friction loss. So whenever the pipe is long, that time the friction loss is there. So friction losses means the major loss is there. Okay. So the next part is for minor loss. So next part, that is nothing but minor energy losses. So these are the criteria in a different parts, that is sudden expansion, sudden contraction, bend in pipe, pipe fitting, and obstruction in pipe. So these are the called as a minor energy losses. So sudden expansion means the pipe is having small diameter and after some time, or you can say after some distance, it can be elongated, that means expanded. So that time the loss will be there, that momentum loss is there, that is called as sudden expansion of pipe. So if you consider for sudden contraction, suppose diameter is maximum and it goes to the reducing, so that time it is called as sudden contraction. So next part is the bend in pipe. So bend in pipe means pipe is bent, so that type of loss is called as bend in pipe. Then pipe fitting, so different pipe fitting is there in our market. So this is the way for the so this is the causes for minor energy losses. Then obstruction means obstruct in a flow. So whenever the pipe is there, so whenever the obstruction is there, suppose example is the orifice meter. So orifice meter is there and in that content orifice plate is there. So whenever the flow is there, so the momentum loss is due to the orifice plate. So that loss is loss is actually minor loss is there, but that is called as obstruction in a pipe. So this is the criteria for major and minor losses. So again I repeat, the major loss is nothing but friction loss and minor loss is different, that is sudden expansion, sudden contraction, bed in pipe, pipe fitting and obstruction pipe. So for major losses we can calculate by a different way. One is the Darcy-Weisbach and Chase's formula. So they are the two formula for measuring the major energy losses. So when the fluid is flowing through a pipe, a fluid experiences some resistance due to some of energy can be lost. So this lost energy can be determined by the two methods, that is minor and major. So in some cases minor losses is neglected. Okay. Now we will discuss regarding the loss of head due to friction, that means major loss. Okay. So first of all we calculate for the Darcy-Weisbach formula already we discussed. So we are to discuss this first. So major loss is calculated by Darcy-Weisbach and Chase's formula. So first of all we discuss regarding the loss of head due to friction, that is by Darcy-Weisbach formula. So here we will discuss the expression for loss of head due to friction. So first of all we considering the uniform horizontal pipe which is having steady flow, and here the 1-1 section and 2-2 section is available at the sides. So P1 and V1. So P1 is pressure intensity at section 1 and V1 is the velocity at section 1. Then length. The L is the length of pipe between 1 and section 2. Then D is diameter of pipe, that is small diameter. Then F dash is the frictional resistance per unit weighted area. Then HF is the head loss due to friction. And P2 V2. HF means friction loss between section 1 and 2. P2 V2 are the values of corresponding at section 2. So this is the information regarding the that pipe. So actually we are applying the Bernoulli's theorem for calculating the Weisbach formula, Darcy-Weisbach formula. So as you know that for section 1 and 2, the P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2 plus HF. So P1 by rho g means pressure head, V1 square by 2g means velocity head, Z1 is means the potential head. So or can say datum head, potential is there. So datum head is there. So P1 by rho g is the pressure head, then V1 square by 2g is the velocity, Z1 is the datum head. So these are the heads at section 1, and section 2 plus HF is there because whenever the initial is the loss is less, so this can be nullifying effect by this HF. So that's why we can add HF over here. So this is the application for Bernoulli's theorem for real fluids. So the pipe is horizontal, that's why Z1 and Z2, that is datum head, is same, because whenever we can take a reference and we can calculate the height, so same will be there. That's why Z1 Z2 will cancel out, and we can write the this cancellations will be takes place. And then V1 and V2 is same diameter, so V1 is V1 as V2 is same velocity because of same diameter of pipe is there. So same diameter means same velocity, so this also cancel out. So only the term remains P1 by rho g is equal to P2 by rho g plus HF. So again I repeat this term. So Bernoulli's equation we apply for section 1 and 2. Only we have added word plus HF because of nullifying the effect of the losses. That's why I can add HF. HF means head loss due to friction. Now in first case we consider here Z1 is constant, because constant means same because of pipe is horizontal, and V1 V2 is same because of same diameter of pipe. So we have, whenever we considering these terms, we can cancelling out the V1 square by rho g and V2 square by rho g. Z1 and Z2 only remain terms as P1 by rho g is equal to P2 by rho g plus HF. Now HF is equal to P1 by rho g minus P2 by rho g. So this is regarding the relation for head loss due to friction. So equation number 1. So now we apply for Faraday experiment, that is that in that suggested that the frictional resistance. So frictional resistance means frictional resistance per unit weighted area per unit velocity into weighted area into velocity square. So frictional resistance per unit weighted area per unit velocity is F dash into weighted area, that is pi dl. Why we consider this weighted area pi dl? Because we are considering the length L over here, because the fluid is crossing this 1 and 2 sections and over the this wall of pipe. That's why we are considering the weighted area. So this weighted area is pi dl, that is nothing but circumference, and into this v square. So this is your velocity square. So this Faraday experiment suggested this this is the frictional resistance formula. Now we know that the weighted area, that is pi dl, velocity v, then that becomes pi d. So instead of pi d we can say p, because p or p is equal to pi d means perimeter. So p is equal to pi d means perimeter. So we can put pi d instead of pi d is the p l v square. So that's why f1 is equal to f dash into plv square. So this is f1. F1 is the frictional resistance. So this is equation number 2. So for Darcy-Weisbach formula, this first equation is from Bernoulli's and second equation is from Faraday's experiment. Now we apply the forces acting at the pipe sides, that is section 1 and section 2. So for pressure force, so pressure is equal to what? Pressure force upon area. So pressure force means pressure into area. So that's why this is P1 means pressure into this area. So area is same because pipe diameter is same. That's why capital A only we write instead of A1. Okay. So P1A. Similarly for pressure force at section 2, that's why P2A. Before here also diameter is same. That's why instead of A2 we can write A, because both the area is same, and then P2 into A. Okay. Now the frictional force. So that frictional force F1. Already discussed this according to Faraday's experiment. That is F1. So that F1, whenever the fluid is going on that side, that is left to right. So when that on a left right hand side, there will be opposing force, that is friction force will be there. So resolving these forces in horizontal directions. So P1A, that is pressure force at section 1, is from left to right. So left to right means what? This is positive, and for section 2 too, that P2A. So this is P2A. This pressure force is opposite of that, because whenever the equal and opposite direction, that is network of relations is there. That's why P1 is left to right and P2 is right to left. So this is opposite forces. We resolve it. That's why P1A minus P2A and minus F1. Minus F1 why? Because friction also in opposite manner. So that's why minus F1. So this resolving forces in a horizontal directions. So we can write as a P1 minus P2 into A. Here only we can take common A equal to F. So this minus F1 becomes plus F1, and according to Ford experiments we write F dash into PLV square, that is from equation 2. So after that this A we can transfer over there, F dash PLV square upon A. Now we go for the equation number 1, that is P1 minus P2 by rho g is equal to HF. So that means P1 minus P2 is equal to rho g HF. So instead of P1 minus P2 we can write as a rho g HF is equal to F dash PLV square by A. So here this P1 minus P2 we can replace by rho g HF. Rho g HF, F dash is as it is PLV square upon A. So we can take like this, then we can solve like that HF. So only we transfer this rho into G is on that side, that means HF is equal to what? F dash upon rho G into P upon A into L into V square, that is equation number 3rd. Now we know that P upon A, P means weighted perimeter and this capital A means area. So weighted perimeter is pi d and area is pi r 4 d square. So after cancellation of that we can get the 4 by d. So we can take 4 by d as it is. So instead of P upon A we can write 4 by d because of weighted area, that perimeter and area is there. So that's why we can take 4 by d. Then after calculations or can say we can take a conclusion, that is HF is equal to F dash 4 V square upon rho GD. Equation number 4 is there. So instead of F dash upon rho, we can take F by 2, where F is known as a coefficient of friction. So this is standard method. So we are observing this phenomena, that is F dash by rho G, and we have finally concluded that by F by 2. Okay. So now instead of F dash by G, sorry, F dash up by rho, we can write F by 2, and we can rearrange the term, and then formulation this HF is equal to 4 FLV square by 2 GD. So this is the formula for head loss due to friction. That means this is for Darcy-Weisbach formula. Okay, so this equation is commonly used for to measuring the loss of head due to friction in the pipes. So this is about Darcy-Weisbach formula. So this is formula for Darcy-Weisbach, that is head loss due to friction, that is a 4 FLV square by rho GD. So here F is frictional, that is coefficient of friction. Then capital L is length of this pipe, V is the velocity, then small d is the diameter of pipe, and after that we get the value for the where HF is equal to loss of air due to friction. Then L is length of pipe, V is the velocity, then small d is diameter of pipe, small is the coefficient of friction. Now small f is equal to 16 by re. So whenever if you require this f, so that time we can go for 50, that f is equal to 60 by re. Re means Reynolds number. If it is the Reynolds number is less than 2000, then this flow is called as viscous flow. Okay, then if you less than, first of all we calculate the re, that is Reynolds number. So re formula is rho vd upon mu or vd upon nu. So we can use one of that formula, that is re is equal to rho vd upon mu, and if it is this Reynolds number is less than 2000, then we can say that viscous flow is there. So we can take a f is equal to 60 by re. Then next, the re, that is Reynolds number, is varying from 4000 to 10 raised to 6 power. Then that time we can use this formula for friction, that is F is equal to 0.079 divided by re raised to 1 by 4. So this is the formula for second. Whenever the 4000 and 2 raised to 6 is there, so we can directly take the F and just put the value over here and then take the F. Otherwise, if it is less than 2000, then we can put the value over here, and then this formula we can give the value of friction, the factor, that is coefficient of friction. So this is next formula, that is Chayes formula. So as we know that the Darcy-Weisbach formula is applicable for to find out the friction, or can say loss of energy due to friction. Okay, and for that purpose, if you require this HF, so if you know the F, so for calculation of F, so these are two formulas, that is 60 by re for re raised to less than 2000. So that time you can use this formula. If it is RA is 0.079, or you can say R is less than 4000 to 10 raised to 6. So in between that is there. So that time we can take the formula, that is F is equal to 0.079 RA raised to 4, 1 by 4. Now we move for the next formula, that is Chase's formula. So we use the equation number 3. So we know that equation number 3 is, what is that equation number 3? That is F dash by rho g P by A LV square. So this formula we can take as it is. Okay. So here we can take this relation as it is, that is HF is equal to F dash by rho g into P upon A into L into V square. So this is about the HF. So HF is equal to head velocity to friction, A is the area of cross section, V is equal to mean velocity, P is equal to weighted perimeter, capital L is length of pipe, and for that purpose we know that the hydraulic mean depth is equal to M is equal to A upon P. A means area of flow, P means perimeter. So if you know that A is the pi by 4 d square and capital P is pi d. So capital A is equal to pi by 4 d square and then P is equal to pi d. So after calculation and solution we get the value of hydraulic mean depth, that is d by 4. Okay, so this is about the hydraulic mean depth. Now we move for the solution. So we can write here equation number 3 as it is, and then small m we can put directly the view that d by 4. So if you take this value, then we rearrange the term, that is v square is equal to hf rho into rho g f dash into m into 1 by l. So after that we will get the v is equal to square root of rho g f dash into m into hf by l. So we can separate this term, two terms, that rho g upon f dash is equal to c, then hf upon l is equal to I. So after that we will get the value of v is equal to c square root of rho g f, that means rho g f, that means c. Okay, then square root of m as it is, and hf by l, that is head log to friction per unit length, is capital I. Okay, so this is about the frictional hf, that is head log to friction divided by length. Okay, so this is the value for finding out the v is equal to c root upon c into root of mi. Now we discuss the Darcy-Weisbach formula. Again I repeat this, whenever the calculation for major loss we can go for HF. HF is equal to 4 FLV square by twice GD, and the HF is equal to head loss due to friction. So if the loss of friction for calculation F is required, small f is required, that time we go for the that RE is to we calculate first RE. So if it is RE is less than 2000, then we can go for this formula. If it is more than 4000 to 10 raised to 6, we can put over here. So this is regarding the Darcy-Weisbach formula. Then Chase's formula is equal to V is equal to C root of MI. So C is the constant of Chase's constant. Okay, M is the hydraulic mean depth, that is d by 4, and I is equal to HF by L, that is nothing but I is nothing but loss of head. So these two formula for finding out for head loss due to friction. Now we will do the discussion on problem. So first problem is find lost head due to friction in a pipe of diameter 300 mm and length 50 meters. So L is equal to 300 mm. So convert this meter. Length is 50 meter. So we take as it is, 3 meter per second velocity is there. Then this also same. Then C, that is C equal to 60, because C means change is constant, is equal to 60. Then kinematic viscosity, this kinematic viscosity is 0.01 stoke. So already we mentioned here, take nu for water, that is 0.01 stoke. So for conversion for stoke to meter square per second, we can multiply this to 10 raised to minus 4. So kinematic viscosity is equal to 0.01 into 10 raised to minus 4 meter square per second. Now we go for first formula, that is Darcy-Weisbach formula. So formula is HF is equal to 4 FLV square by 2 GD. So F is the coefficient of friction and is a function of Reynolds number. So first of all we go for Reynolds number. So as we know that there are two formula for Reynolds number, that is rho Vd upon mu or Vd upon nu. So V is the velocity, we can take as it is, that is 3 into into that diameter, that is small diameter is there 0.3, and nu is there, that's why I can take 0.01 into 10 raised to minus 4. So after calculation, that 9 is r is equal to 9 into 10 raised to 5. So that is why we can take this formula, that is f, that is 0.079 raised to re raised to 1 by 4. So that time we can put the value of re, that is 9 into 10 raised to 5, and then we get the value of 0.00256. This is friction factor. Now we put the value for the Darcy's formula, that is f is known to you, L is known to you, V is also known to you, D that is 0.3, and 2 as it is G 9.8. After that we can calculate the HF, that is 0.7828 meter. Now we go for the next formulation by Chase's formula, that is V is equal to C under of Mi, then C is equal to 60, then M is equal to D by 4, that is 0.30 divided by 4. We put the value of C over there, C and M. So we put this C and M. Then after that we can put the I over here. So I means HF upon L. HF means head loss due to friction per unit length. So that's why we can take L is equal to 50. Now we can equating these two values of I. We have HF by 50 is equal to 0.03. That is HF is equal to 1.665. So this is about head loss to friction. Now we move for the next problem, that is crude oil of kinematic viscosity, that is 0.4 slope. So first of all we convert this meter square per second. Then the flowing through a pipe of diameter 300 mm. So diameter is 300 mm and the Q, that is 300 liter per second. Find the head loss due to friction, that is HF, for the length is 50 meters. So given data is nu, that is 0.4 slope, that's why I can convert this 0.4 into 10 to minus 4 meter square per second. Diameter of pipe, that is 300 mm, 0.3 meter, 300 liter per second, that's why we can take 0.3 meter cube per second. Then next, length of pipe, that is 50 meter. Then velocity is equal to Q upon area. Q is equal to 0.3. So that is discharge, that is 30 liter per second, so 0.3 meter cube per second. Then area pi by 4 d square, so d is small, that is 0.3, we can take 0.3 square. After that we get the value of V, that is 4.24. Then after that we go for Reynolds number, that is Vd upon nu. So V is the 4.4, D is the diameter of pipe, that is 0.3, then divided by 0.4 into 10 to minus 4 nu. So directly we will get the value of Reynolds number, that is 3.18 10 to 4. Then the RE lies between the 4,000 and 10,000. The value of F is given by F is equal to, so this is more than 4,000, so that's why I can take the relation, that is F is equal to 0.079 RE raised to 1 by 4. So after that we can put the value of the 0.079 divided by 3.18 into 10 to 4 raised to 1 by 4. So after that we will get the value, that is 0.00591, that is your friction, that is coefficient of friction. Okay, now we take this F and V. So F is known to you, V is also known to you, length is also known to you, and diameter is also known to you. That is why HF is equal to 4 FLV square by twice GD. So F is equal to 0.00591, then V is 4.24, V, that is, then L is 50 meter, then small d is 0.3. So after putting this value, this equation becomes like this, and after that we can calculate the HF, that is 3.61 meter. Similarly we go for changes. So this is the regarding the only about the head loss due to friction. So we either we go for the Darcy formula or Chase's formula, but here the Chase's formula, that C is not given, that's why we can identify that this is only for the head loss due to friction, that is HF is equal to 4 FLV square by twice GD. So in this session we already discussed the classification of losses of head due to friction and other losses, that is major loss and minor losses.